As our room chart table stands now, it's got 3 fields and 5 records. 2 of those fields are fixed length data fields, and 1 is a variable length data. Now we want to go in and redesign this table to have a 4th field. So we're going to go in to the design view. We're going to add a field called room description. And we want the description to be a lot longer than the name. For example, the Renault Langsford Tribute Room will be described as, "This room is perfect for customer previews." So an nvarchar 25 is not going to hold that. And sometimes we might have a very long description. So we're going to go ahead and pick an nvarchar 200. So we can have up to 200 characters in that one field. We will save this. Close it, rerun the query. Notice we have room for a room description. Well, let's start populating some of that. Let's edit the top 200 rows. And let's put here, this room is designed for customer previews. And I'll click away so it accepts the change. Close out of here, and we see this room is designed for customer previews. Now, it didn't take up all 400 bytes or 200 length of characters, but we have up to that much room. Now, let's put in some more data. Parties and morale, events, get top priority. So after populating some new records with variable length descriptions of the rooms, this could be a possible result. Now, every once in a while, we want to put some sort of notes that belong with the room. For example, in the Renault Langsford Tribute, they might want to say, "This room is designed for customer previews." Note, the famous explorer Renault, who came to this region with his family and started upon ourselves a community in 1874, blah, 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 and it goes on and on and on. And it's like one of those things you read on a display at the museum, and they want to be able to fit that there. So we go back to the design view, and we say, you know what, this thing could go on pretty long. We're going to have an nvarchar 10,000. And it says, well, wait a minute. The biggest an nvarchar can go is 4,000. What are you going to do if you want notes that go past 4,000 characters? Well, you probably want a different data type. Room, notes, that is an n text. Now, if you didn't need Unicode, you could just do text. There's a potential performance hit, and that's what this lab is going to be all about, exploring the difference between regular data types and large object types. Room name is an nvarchar 25. Room description is an nvarchar 200. How come I can never have an nvarchar beyond 4,000 lengths of characters? The reason is all regular data types are limited to 8,000 bytes. If that's the case, then how big could a varchar be? Well, let's try something out by going to the design view of the Human Resources table and knowing that an nvarchar 4001 is just over the limit. What about a varchar? Now remember, a varchar is 1 byte per character. A varchar 8000 is perfectly acceptable, whereas a varchar 8001 would be just beyond the limit. The maximum amount of space a single row would take up in the table design above, if you consider the header, the fixed length data, the null block, the variable block and the variable length data, and you do the math, you would see each row could take up to 473 bytes. Rows are meant to fit into what's known as a page of data. A page of data is just over 8,000 bytes. Your database operates most efficiently if each row fits into a page. Now, many rows can fit into a page, and that's still efficient. The second most efficient thing it can do is, if the rows do get big, at least every field can fit into an 8,000 byte range or less. Therefore, data types that limit themselves to 8,000 bytes or less operate very fast and very efficiently because they can fit in the organized pages of memory. Though if one or more records being able to fit in a single 8 kilobyte page of memory is the best, how does our room chart table shake out? Well, since our room table is going to take up to 473 bytes per row, and we have 8,000 bytes of capacity, looks like filling the first row at a maximum still leaves 7,500 or more bytes free. Therefore, it looks like we're going to fit about 17 records into one page. That's going to work for fast and efficient retrieval. So knowing that my ID field, my code field, my room name field, and my room description field will always fit within an 8 kilobyte page, what would happen to this first row if the room notes field actually had 10,000 bytes in it? What if it had 2,000? What if it was null? The reality is, when you have a large object type, like text or ntext, SQL doesn't want to take any chances. So, the room notes field is actually data that is not stored within that row. It is reserved to another part of memory, and SQL links the two together when you query or when you update or when you do insert statements for this table. What's really stored within this row are the regular data types. The large object types, they give you capacity you didn't used to have, but they kind of got to be managed by SQL Server in a separate memory space, which can cost you processing time and performance, so only use large object types if you need them. Let's take one more look at the room chart table in its design view. Now, why did we choose ntext for this field? Well, the reason is we wanted Unicode, and we thought we would go over the 4,000 character limit, which is over 8,000 bytes. We want to be able to hold that, even if it's a performance hit. Now, after populating many records, we've discovered we rarely do that. So how can you create a Unicode type that, if it's small enough for each individual record, it's going to throw it in with a page row that the other fields are with, or if it goes over the limit, then just for the records that go over the limit, let's treat that like a large object. So it's going to be treated like a regular data type when it's small, and a large object for the rows where it gets large. Well, let's do a side-by-side comparison and call this room notes 2, and let's make this an nvarchar max. And an nvarchar max is new to SQL 2005 and was continued in 2008. This way, if the vast majority of your data rows are going to be under the limit for that field, you get the performance gain. But you don't have the limitation of size, because it will store it as a large object if any particular row or rows happens to go over. Lab 3.3, Skill Check 1. Go to your current products table in the JProCode database and change every variable length character to its counterpart that will allow it to be the maximum size without making it a large object unless that row actually goes over the limit. When you're done, you'll be done.